Good afternoon, everyone. Thank you for introduction. During this presentation, I would like to show you how I try to estimate human impact in a southern Poland. My study area is part of a Krakow-Silesian formation, which consists of Triassic carbonates rocks. And based on the geological structure, tectonics, and groundwater flow dynamics, it was divided into 5 major aquifers. The 5 major aquifers: Lubliniec-Myszków on the north, Olkusz-Zawiercie, Chrzanów, Bytom, and Gliwice. The study area is major groundwater basin Gliwice, together with Tarnowskie Góry area, which partly belong to the major groundwater basin Gliwice and partly to the Lubliniec-Myszków aquifer system. What is important, the southern part of the Gliwice system and the eastern part belongs to one of the most industrialized region in Europe. It is called Upper Silesian Industrial Region. And the aim of this study was the evaluation of human impact on this area. Groundwater occurs in Quaternary and Triassic rocks, but the main aquifer is Triassic aquifer. It's a reservoir of potable water using for communal, industrial, and agriculture purposes. The Triassics consist of Muschelkalk and Ruthenian age rocks. It's mainly limestone and dolomites. And this aquifer system is a triple porosity system, fissured, karst, porous, but the karst is not very well developed and it's mainly in an unsaturated zone. This aquifer is intensively pumping, and the well fields are distributed along the all model domain. Oh, sorry. The land use in aquifer Gliwice system is dominated by an agriculture area. Only the southern part and the eastern part is urbanized, this part here. And in Tarnowskie Góry, the north part is dominated by forest cover, and the urbanized area is mostly in the center and south. FEFLOW model have 150 kilometers square, and steady state model for 2010. It's built in a regional scale, and during mesh development, it was refined around the faults, which in this area act as semi-permeable barriers, and also around pumping wells. The outer boundary conditions are the first and the third kind boundary conditions, and in the eastern part, where the post-mining area occur, the 2 deepest dewatering adits was also included to this model by means of one discrete feature element. The groundwater recharge for this model was estimated based on soil and water assessment tool. And after that, during the model development in Tarnowskie Góry was also calibrated. Here is the first result of groundwater modeling. And in major groundwater basin Gliwice, the general flow is from east towards southwest, but it's strongly deformed by working well fields. And the biggest well fields is located in the southern part, is the Gliwice-Łabędy well fields, which pumping average 30,000 cubic meters per day. The precipitation is, the recharge from the precipitation is the main recharge in the water balance components. And from the other side of the water balance, the drainage is is dominated by pumping wells. It's nearly 60%. And in the east part, also important is mine gallery drainage, nearly 20%. So together, over 75% is a artificial drainage induced by human activity. In order to show how big influence the groundwater well fields takes in this area, we make a scenario when we stopped pumping by this well, and effect of ceasing pumping in the Gliwice Bendy caused that rebound of head is over 5 meters, covers the area of 220 kilometers. The maximum head rebound was in well 6B, is located here. And also, result of ceasing pumping is decreasing infiltration of Drama River. Okay, in Tarnowskie Góry area, the water withdrawal is significantly smaller due to contamination of chlorinated solvents. And we see that the contamination is also spread now over the Tarnowskie Góry area, and another well are contaminated. Therefore, because the water is contaminated, so we can't use this water. So we see that the water rise in this region about few to maximum 20 meters. And if you assume that the total groundwater recharge is nearly 44 cubic meter per day, and the pumping, and we add the pumping and mining gallery, we can see that nearly 65% of renewable resources is induced by human activity. And because we know that the water in mine gallery is also contaminated, and 3 wells which pumping water contaminated and used for industrial purposes, so we can estimate that at least 43% of the renewable resources in Tarnowskie Góry cannot be used for drinking purposes now. On this slide, I would like to show you how we try to estimate artificial recharge in urban areas. We have here 4 cities and estimated leakage from water network for the cities. And we can see that the loss of water is the high in Tarnowskie Góry area. It's over 25%. And what's also important when we take into consideration that the water network in Tarnowskie Góry is reduced only to the center, is southern part, we can estimate that at least 10% of the total groundwater recharge in this area is caused by leakage from this water network. In eastern part, we have also a post-mining area. The area is known from excavation of iron, lead, zinc, and silver. And the mining activity started in the prehistoric time and over at the beginning of 20th century. And the legacy of ore mining is now about 20,000 shafts and 4 shafts, over 20 kilometers of mining workings, and 9 adits. Some of these empty spaces are in unsaturated zone, and some are fully flooded. Today, this area is used as touristic attraction, so you can take a trip by a boat, and is also a habitat for 10 protected different species of habits. And as a result of this post-mining area, the groundwater recharge in this area is quite high. This is the focus on the most the part which have the most the biggest amount of workings and the empty spaces in the rocks. And this is the area of the densest mine gallery network. And if you compare to the groundwater recharge results, you can see that here the groundwater recharge is the higher, and it's about 250 millimeter per year to 380 millimeter per year. So it's about 33% of the annual precipitation. What's also I'd like to show is that basing on environmental tracer, we estimated that in this mining area, is very short resident times of water, and based off SF6 and tritium data for wells in the southern part of Tarnowskie Góry, even if I screened very deep, for example, from 100 meter to 170 meter, the age estimated was about 10 to 15 years. In the northern part of the Tarnowskie Góry, the average age of the water is between 20 to 40 years. And system of mine gallery simulated in the FEFLOW, efficiently lowering the water table to 255 to 160 meters above sea level. And the volume of discharge depends on groundwater recharge, but also how many wells are stop pumping in the Tarnowskie Góry area. So let's go to conclusion. So in order to estimate human impact in this region, we built a groundwater model using FEFLOW code. The groundwater flow is strongly deformed by pumping wells in this area, and the drainage induced by human activity is over 75%. Ground recharge is the biggest in the eastern part where the post-mining area exists, and is over 30% of the total precipitation. And additional recharge is associated with leakage from water supply system, was estimated in Tarnowskie Góry at about 30 millimeters per year. And over 40% of renewable resources in the city can be used due to TC and PCE contamination. And the project was funded by National Science Center. Thank you for your attention.